Hello everyone. In today's lecture, we are going to discuss about the communication protocols. Okay. So what is the communication protocol? Communication protocols are those which helps to transfer data to communicate with another device. One device wants to communicate with another device to transfer the data. In order to transfer the data from one place to the other or one device to the other, communication protocols plays a major role. Okay, the following communication protocols have immediate importance to consumer or and industrial IoTs. So these are the different IoT, the communication protocols that we can see. IEEE 802.15.4 is one kind of communication protocol used to transfer the data from customer to the customer and producer. Okay. Zigbee is another communication protocol. 6LoWPAN, wireless HART, Z-Wave, ISA 100, Bluetooth, NFC, RFID. Okay. These are all different communication protocols that are used. Okay. So first thing is what IEEE 802.15.4 is the first communication protocol. Okay. So we'll see the features of this. A well-known standard for low data rate weapon, the WPAN. Okay, so developed for low data rate monitoring and control applications and extendable life, low power consumption uses. Okay, it uses what? Low power consumption. The standard use only the first two layers, either physical or MAC. Okay, plus logical link layer LLC and services and sublayers like service specific convergence sublayer. Okay, SSCS. Additions to communicate with all upper layers. Okay, operates in a ISM band. These are different features available for IEEE 802.15.4. So this is an small structure shown. Okay. So where this IEEE 802.1.1 place in a data link and a physical layer. In these two layers, will be this IEEE is used. It means that so in order to transfer at the low level like LAN, Bluetooth, Wi-Fi, everything, it comes under physical layer and a data link layer. Okay. Now, like similarly, there is an IEEE standard, which is 802.15.4 is a standard used in a data link layer or a physical layer. In these two layers, this protocol is going to be used. Okay. Then uses direct sequence spread spectrum modulation, highly tolerance of noise and interference, and offers link reliability improvement mechanisms. It means the highly tolerant of noise disturbances. Like during the transmission of data, there might be a collisions between like I'm transferring data and some other person also wants to transfer the data to the same device. Then there may be a noise problem. It means there might be any disturbances during the transmission. So highly tolerance of noise and interference on these two can be handled with this standard and offers like reliability improvement mechanisms. Low speed versions use binary phase shift. Low speed versions use binary phase shift keying. High data rate versions use offset quadrant phase shift key. So these two are the keys which are used when you want to send the versions, like when you want to set a key with the low speed versions, uses binary phase shift key. When you want to use high data rate versions, in that case, you'll be going to use offset, sorry, offset quadrant phase shift key. Okay, uses carrier sense multiple access with collision avoidance. Okay, for channel access. To access the channels, they use what? Multiple access. Okay, carrier sense multiple access with collision avoidance is used. Okay, multiplexing allows multiple users or nodes interference free access to the same channel at different times. Okay, power consumption is minimized due to infrequently. Power consumption is minimized due to infrequently occurring very short packet transmissions with a low duty cycle, that is less than 1%. The minimum power level defined is minus 3 dBm to 0.5 MW. Okay. So transmission for most cases is line of sight. Okay, transmission of most of this in many cases it follows line of sight. Standard transmission range varies between 10 m to 75 m. Best case transmission range achieved outdoors can be up to 1000. So these are the standards, like when you are transferring the data, these are the levels of transferring. So networking topologies defined as a star mesh. These are the topologies that used when you want to use these protocols. Okay, IEEE 802.15.4 variants, base version. Okay, C for China. Let us assume these are all different areas. Okay, we want to achieve RFID and use utility network services. Okay, so look at this different types. Networks are non-beacon enabled and beacon enabled. Okay, so FDD, RFD. These are divided into three parts, and it is containing of same one part, that is a device. If for FFD, you need a PAN coordinator, router, and a device. FFD, as we have seen here, FFD and RFD. FFD is a PAN coordinator, router, and a device. It requires all these things. RFD is only a device is enough. So full function device can talk to all types of devices, supports full protocol. Reduced function devices can only talk on FFD, lower power consumption with the minimal CPU and RAM required. Okay. IEEE 802.15.4 frames, beacon MAC command, acknowledgement, data. These are all comes under the one frame. Okay, one frame. In a single frame, these are all required: MAC, beacon, command, acknowledgement, and a data. Now we'll see the ZigBee. Okay, ZigBee is another protocol which is used for communication. So these under ZigBee, the features are most widely developed enhancement of the previous one. So it is an enhancement version of 802.15.4. Okay. The ZigBee protocol is defined by layer 3 and above. It works with 802.15.4 layers 1 and 2. The standard uses layers 3 and 4 to define additional communication enhancements. These enhancements include authentication with valid nodes, encryption for security, and a data routing and forwarding capability that enables mesh networking. The most popular use of ZigBee is wireless sensor networks using mesh topology. So different layers. Okay. So in the top of about third layer, in all these layers, ZigBee can be applicable. Important components are ZDO APS. ZDO is Zigbee Device Object. APS is Application Support Layer. Okay, so device management, security, and policies will be handled by Zigbee Device Object, and application support sublayer is going to take care of interfacing and control services and bridge between network and other layers. Zigbee topologies. See, star and mesh we have seen, right? So cluster T is also a part of the like star and mesh is for 802.15.4 version, and Zigbee adds another topology, that is cluster tree. Okay, so if you can see all the blue lines or blue dots colors shows the router, and the red part is shown as a coordinator, and the green part is the end device. Zigbee mesh. In a mesh, any node can communicate with any node within its range. Okay. If nodes are not in range, messages are relayed through intermediate nodes. This allows the network deployed over large areas. Zigbee mesh. Meshes have increased network reliability. For example, if nodes C and F are down, the message packets from A can still be relayed to G over B and E. Okay, so Zigbee mesh networks are self-configuring and self-healing. Zigbee coordinator. These are all similar points to those, like storing on the network and single Zigbee coordinator in each network, and coordinator forms like route to the Zigbee network tree. These are all comes under Zigbee coordinators. So network layer under Zigbee, under network layer, uses ad hoc on demand distance vector. Okay. To find the final destination, the AODV broadcast a route request to all of its intermediate neighbors. The neighbors relay the same information to their neighbors, eventually spreading the request throughout the network. Upon discovery of the destination, and a low-cost path is calculated and informed to the requesting device via unicast messaging. The applications that are used for these Zigbee are used for many applications. So some of the examples are building automation, remote control, smart energy for home energy monitoring, healthcare for medical and fitness monitoring, home automation for control of smart homes, light link of control of LED lighting, telecom services. So with this, we have completed the communication protocols. Okay, thank you. We'll continue the next part, that is sensor networks, in our next lecture. Thank you.